So our last speaker before the lunch break is Boris Lau, and he'll be speaking about the high and low of a Python data stack. Make him welcome, please.
Hello, hello. Can you guys hear me? Okay, that's great. So at the start of this conference, most of us actually start our presentation with a bit of confession. So I'm going to start with that also, and I have to confess that this is not Python 3. In fact, actually, recently I've been to PyData 2016 in London, and before I went there, I actually didn't realize all the things that's going on within the PyData stack. So I kind of like went there and would go, wow, there's so much things that's going on. So I kind of really want to bring back a bit of what I've learned from that conference and talk a bit more about that. Actually, just a raise of hand, anybody here use anything on the PyData stack, like I have notebook, pandas? Wow, that's quite a few people. That's great. So maybe you guys. Done. Okay. Okay. Great. Okay. So a bit of introduction about myself. My name is Boris. I actually started far away from Python. I actually started as a computer security reverse engineering, looking at disassembly code. And how did I get into Python is that I was actually using Python to script some of the disassembly tool that I use, and from there on, I actually got quite deep, and then went into started a company which is a full stack Python shop. So we kind of like go in and out using different Python modules, and then now I'm actually at Mobify, and I'm really focused on making the data part work. So what's the PyData stack? A lot of people have different definition of it. So I'm going to define PyData as an ecosystem of open source Python packages that is partly related to a nonprofit organization called NumFocus, which support and sponsors a lot of things that's happening in that open source community, making the PyData conference happen. Actually, anybody here from Continuum working here? Thanks so much for the work. So Continuum is actually closely related to the whole stack there, and they build a lot of the cool stuff that we're going to demo here. So it's really cool to have someone here locally in Vancouver from the Continuum shop. This diagram is tiny. I actually don't like the stack how they're organizing it. So I'm using my elite Photoshop skill, photo cut skill, to make this stack. So just to illustrate what I'm talking about here. So the high level wise, you get the platform. I define platform as something that you actually interact with as a developer. So echoing what Don just said, it's really important for developer to get fast feedback loop. And we're trying to make that happen with data, which is why we have iPython notebook here. And then we've got the visualization stack, what you see, like how do you visualize the data that you have. The model, which is kind of like how you modularize all the knowledge. For example, the stats model, or the cool machine learning algorithm that's happening. And then you've got the data access layer with pandas, where you are talking to the API that defines how you talk to the data, as well as makes all the data access seamless and easy. And then on the bottom of the stack, you've got a bunch of optimization that's happening that you might not need to touch directly, but that's some really cool things that are going on in there. I'll just talk a bit about that also later on. Here's the full list of the stack. I won't go into every single part, but just wanted to show some of the things that's cool within this stack from your eyes, essentially, to the bottom of what your CPU is running. So talk about platform first, the high level. So it's on a platform. One of the platform by choice on PyData is iPython notebook. So it's a platform that allows you to do a lot of the data playing around, for example, getting repair loop, just like Don had done, but on the data side. As well as you can actually share results. So for example here, actually this presentation is done within an iPython notebook. So I can actually go in here and do like it's actually really hard to do live coding. Okay. I'm going to do the simplest program in the world instead of the second simplest program. So yeah, you can actually do a lot of things like this and basically get a repair loop that's going on in your environment here. Yay, it came out. Sweet. Okay, so it's really, it allows you to get a really fast feedback loop, not actually a reload style feedback loop, but actually allows you to access your data really quickly. The second level of the data stack that I want to talk about is the visualization layer. So by default, the PyData visualization has got quite a few different libraries, but one library I want to show here is the bouquet. It actually allows you to do interactive visualization within your IPython notebook. So for example here, you actually get a visualization that you can actually resize, zoom in, and if you are clever enough, you can actually do a lot of interactions with it. So it's very useful this way. The next stack I want to talk about is the model layer. Actually, now I look at it, I actually can't regret choosing a name model because it's essentially just like importing a lot of smartness from different people that's working on that makes it happen. And it's quite confusing because if you think about the MVC layer that we talk about, this is actually kind of the controller layer, while the data is actually the model layer. And then the view is kind of the visualization IPython layer. So I think of it as like make me smart layer. So for example, I'm actually not a big machine learning person, but actually just by some simple coding that you are able to get a SVM linear classification going. So it's a lot of good examples there that you can play around with really quickly. If you are trying to tackle a machine learning problem first time, I would really recommend you to check out the sklearn modules. A lot of cool examples there that you might be able to just like throw it on the data that you have and find out, hey, is there something cool that I can play around with? Not enough to be dangerous. So the next thing that we are going to talk about is the data access layer. So on this layer, the main players here is Pandas and NumPy. So Pandas actually provide a really efficient API to access your data in terms of, for example, slicing, grouping your data. It's a lot of the syntax there is influenced by R, so which is really good at accessing the data. Really good at talking to the data. The other side of it is actually how you organize the data. So NumPy is the library that provides you with a lot of linear algebra operations that you have. And it's actually like a lot of magic happening there. But actually, all these is actually really simple. So, well, it's simple to explain in the sense that when you think about you want to store a list, what do you want to do? Store it in a continuous space. But actually, with a lot of time, when you're programming high-level languages, you're actually storing a lot of references of these arrays to the actual data that's underneath. So what NumPy do is that, hey, like, if I know the size of your object, I actually just put it in a continuous space and make it really simple. So that's kind of the fundamental of what NumPy is trying to do. So it actually like allows you to do a few things. So first of all, it allows you to talk to a lot of different other languages. For example, Fortran even use the Intel Max kernel library to do some hardware optimization on algorithm because they all assume that the data is continuous it's an array. So kind of makes it useful to talk to other languages. It's not sufficient to just say, hey, I'm going to glue this Python onto some other language because gluing is easy. Talking, interfacing the data is the hard part. And NumPy actually provides a really good interface for that. So just to illustrate the point about continuous data here, that's down here. So on the higher line there here, on the green line, that's the showing the data, multi-dimensional matrix in raw Python list, while the bottom line is actually showing what the data size is when you store it in a NumPy multi-dimensional array. And you can actually see that's the exponential efficiency in the memory usage here. It's more than that, actually. So the next level that we are going into is the voodoo layer, the low-level optimization of what is happening underneath that. And one library that I want to highlight is Numba. What Numba is actually a library that allows you to do a lot of just-in-time processing and compile your Python code into LLVM code, which then execute it in the native languages. So one of the most used examples to demonstrate power of some of these linear algebra library is fast Fourier transformation. So that's a really good block article that I would recommend you checking into how they actually go from NumPy Python code into a line profiler and then go on and optimize it and eventually write a number function that will just everything in magic really fast. How fast actually? It's really compared to native. It's actually comparable speed to native. Well, compared to Fortran code, which is normally the de facto standard on how fast you can run linear algebra operations. So the top result here, 1.3 seconds. That's the Python speed. Number is 0.063 seconds, and Fortran is 0.041 seconds. So it's within that like 100-factor improvement. 2-factor improvement onto the Python code. So how do they do it actually? What is this magic just-in-time compilation? In fact, we can actually look at the native code as being compiled within the with the number function here. So I took the example of what they have written with the number function with the fast-forward transformation and tried to use the NumPy compiler to compile it in a shared object. And then from there on, you can actually do the disassembly and look at actually how big the function is itself. And it actually compiled it to about 3,000 bytes functions. So it's hard to conceptualize how simple it is or how complicated it is, right? So let's simplify this and actually just look at a really simple function. This is a function that basically just take an integer, add a constant to it. So the simplest of it, and basically in number, you're going to apply over array function, make it ufunc, and basically just apply over a NumPy array. So what does it actually look like in an actual, actually it's already taking an array, I was wrong. So what does it actually looks like with the actual native code? So this is actually just this is actually the compiled native code with that add-ins. So you can see here, it's actually just doing the add operation, moving the index pointer, and then go back and decrease the counter, and then go back and jump around. This is as close as you get, like even if you handwrite this in assembly code. This will probably as close as you write to actually writing efficient code. But in Python, with 2 lines, that's amazing. Well, actually, on hand, you can actually write it in 2 instructions. But that's making a lot of assumption on the data structure that you're using. But that's good enough. Okay, so we kind of go through the whole stack from what you see to what actually happens on the CPU level. So let's take a step back and look at the problem that you're trying to solve. So when I define, hey, what is this good at? I normally take a benchmark and try to compare what other thing existing is out there. What can you define good and bad? So another data stack that is coming from is the Apache data stack. So I just want to make a comparison there. So here's another awesome photo cutting diagram that I have. So on the platform side, Apache has also got a platform called sklearn. It's really good platform that actually, if you put it side by side, you're actually hard to tell between the difference that you're running an IPython notebook or you're running a sklearn notebook, except that if you look at it, it might have more Scala in it. But actually, interesting enough, you can also run Python in it. So recently, there's a conference at Data Talk, which the person is actually writing things in sklearn and then pull it out and go, hey, actually now I'm going to write some Python because the Python visualization stack is much better. So I'm actually going to just put this data and visualize it in Python. On the visualization and modeling layer, it's kind of a bit of difference here. But the main bit I want to talk about here is the Voodoo layer. Why is the 2 stack different? So on the Voodoo side, we already talked about the Python side. On the Apache side, it's actually a lot of distributed technology. So for example, HBase, Hive, Spark, a lot of different technology that try to actually make your problem in a semi-reduced way, distributed across different machines and work on it. So I would say that's the fundamental difference, is that with the Python data stack, you're really good at scaling up, making full use of everything that's happening in your computer, down to the instruction level. While in the Apache stack, it's actually go, hey, let's take a step back. We can actually do all these in JVM and have that abstraction layer, and just distribute this problem across a cluster and pay me the money. I'll spin up as many computers I want and just go and solve this problem in a distributed manner. So which side is better? Actually, it really depends on the problem that you're tackling. So a certain problem that you think is a about, hey, I'm just going to write this loop and I'll throw it on a distributed machine. Well, there is some optimizers that allow you to do that. But on the other hand, a lot of time you actually need to do some actual thinking in terms of making your algorithm run in a distributed manner. So one good example is that. The algorithm that is pain, and you've got to be really careful about what you're doing before you decide to scale out. But actually, looking at the future here, one big thing I learned from the PyData conference is that actually Continuum is already looking at the next stage of how we can scale out on the Python side. So if you can't see that allows you to reuse some of the API on the Panda side, but be able to talk to a distributed cluster. So you can actually talk from that layer, you can link to quite a lot of the existing distributed technology out there, and it makes things really, really fast. Dask, I think, is the optimized. By saying all this stack that I'm talking about, you might think there's a lot of moving parts in there, but actually, in fact, it's a lot. There's a package called the Anaconda package, and it actually download it right away now and get all these things on your laptop without screwing up your Python environment. Now, just from the raise of hands here, I'm actually seeing a lot of people that is into the PyData stack. So I'll actually kind of want to do a bit of trial here, and like if you guys would like to hear more about PyData, I would love to like get you guys to go into this link here, http bit.do PyData Van. So we can get a community together, sub-community of Python together, PyData people together, and talk about the problem and challenges that we have. All this code is written, as mentioned, it's written in an IPython notebook, and it is available on GitHub. With that, thank you very much for your time, and love to